Let's say you have a circle, just a random circle, and from the center of that circle, you make like a slice, something like this. This section, this slice, is known as a sector. Okay? So if I were to draw out that sector separately, let me draw that a little better. Something like this. This line from the center to the edge is the radius. This is also the radius. Sorry, I said edge, I mean part of that circumference. Now, this is referred to as the arc length, or just L for short. And this is all at a particular angle. So your sector takes up a portion of your whole circle. That portion will essentially be determined by the angle. So it could be skinny, it could be really wide. It could be a small pizza slice, it could be a really big one. Okay? Now, there's one equation that you need to know in order to work out the arc length. So in order to work out L, you take the radius and you times that by the angle. One thing to keep in mind is the angle will be in radians, or RAD for short. Just how degrees is a unit for angle, radians is also a unit for angle. And in your calculator, you want to make sure that you're working in radians. The way you make sure you're working in radians, so I've got my calculator next to me. Ideally, you want to have your calculator next to you. And here's what you're going to do. You're going to press at the top left the shift button and then the menu button. Number 2 is angle input. So you're going to go to number 2 and then you've got 3 options: degree, radian, and gradient. You want to press number 2. And now at the top, you should see a little black square with R written on the inside. That's how you know you're in radians. If that black square has D written on the inside, you're working in degrees. So just make sure that depending on the question you're doing, you adjust. But yes, that is the equation for arc length. Super straightforward. So let's go through this example. An arc AB of a circle with radius 7 centimeters and center O has a length of 2.45 centimeters. So we've got the center O, we've got the arc starting from A going to B. The radius is 7 centimeters, so this is also 7 centimeters, and the length is 2.45. It says find the angle AOB, subtended by the arc at the center of the circle. So we're trying to work out this. Easy. L equals R theta. You're going to rearrange. So theta equals L over R. 2.45 over 7. You stick that in your calculator and you should get 0.35 radians, so RAD. Easy. Okay, let's have a look at this question. An arc AB of a circle with center O and radius R subtends an angle of theta radians at O. The perimeter of the sector AOB is P. Express R in terms of P and theta. If you feel like you can do this, give it a shot. Try it now, see what happens. If you're confused, fair enough. I would be confused too. So let me break it down for you. You always want to draw when you can. So let's draw our sector. With the center O and the point A, B. We've been told the radius is just r. And we've been told that the angle is just theta. Okay, the perimeter of AOB is P. So perimeter equals P. What you want to do is you want to try and express P, the perimeter. In order to do the perimeter, you need the radius, which you have 2 of, and you need the arc length. When you add all those together, you get the perimeter. So, can you try and work out the arc length for me, please? L equals r theta. That's the equation for arc length. And your r is r and your theta is theta. So there you go, r theta. The perimeter is r plus r plus r theta. So 2r plus r theta. And now you can simplify this by factorizing out r. Like this. This is all equal to P. We've expressed the perimeter now. However, what does the question ask? The question is asking to express r in terms of P and theta. So, if you make r the subject, that is your final answer. Okay. This question. I want you to give it a shot. See how you manage. Okay, let's go through it. The border of a garden pond consists of a straight edge AB of length 2.4 meters and a curved part C as shown in the diagram. Okay. The curved part is an arc of a circle, center O and radius 2 meters. Find the length of AC. Right. So here's what we can do. Let's draw a triangle. Let's draw that OAB triangle. And let's split it in half. When we split it in half, this line would be 1.2 meters long. This would still be 2 meters, and we don't know the angle. So let's just make that x. So, can you work out x for me, please? To work out x, you would just do trigonometry. So sine x is equal to opposite 1.2 over adjacent 2. Over hypotenuse. This gives you 0.6435 blah 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 rad. Okay. So that's one part of our triangle. The other part, so from all of this bit, would be the same, wouldn't it? So we do 2 times x. 2 times 0.6435 blah 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 radians, which gives us 1.2870 blah 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 radians. Okay? What is the total angle of a circle? 360, which in radians would be 2 pi. 360 degrees is the same as 2 pi radians. Okay? So now, if we want to work out, if I zoom in, if we want to work out this angle here, let me do it in red actually. If we want to work out this angle, we have to do 2 pi minus this angle. That blue one we've already worked out. That's this. So 2 pi minus 1.2870 rad, which is the same as 4.9961 blah 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 rad. Okay? So to work out the length of C, we do L equals R theta, with this being our theta. 2 times 4.9961 blah blah blah, which is 9.99 meters. There we go. That's the arc length. And that is how you do questions involving sectors and arc length.